Dear students, welcome to my channel. Main topic is evaluation of information retrieval system and subtopic is unranked retrieval. In this video, we are going to see precision, recall, accuracy, F1 score with the example. Now let us start. Two types of evaluation are there for document retrieval, unranked and rank. In unranked retrieval, assessing how well a system retrieves all relevant documents regardless of order. Metrics are recall, precision, accuracy and F1 score. It focuses on the comprehensive retrieval. Rank retrieval, evaluating how effectively a system ranks relevant documents higher than the less relevant ones. Typically, it uses a matrix like average precision, normalized discounted cumulative gain, etc. It focuses on the relevance prioritization. Now we will see the basic definition of precision and recall. Precision is the fraction of retrieved documents that are relevant, and recall is nothing but fraction of relevant documents total in the system that are retrieved. Precision is relevant items retrieved divided by retrieved items, and recall is relative items retrieved by relevant items. Now this is nothing but the relevant items which are retrieved. This is indicated by this intersection, and this is actually expected, but we retrieve these documents. So this is nothing but the precision, that is relevant items retrieved divided by retrieved, and recall is relevant items retrieved, that is this, and total relevant items in the system. And this is the graph of precision and recall, and we can see that as recall is increases, the precision is generally reduces, because when we retrieve all the relevant documents from the system, at that time we are retrieving the most of the documents which are irrelevant. Therefore precision is decreases. Now we can represent like this. This is the actual and this is a predicted. Now actual is relevant, non-relevant. Predicted is retrieved, not retrieved. If relevant is retrieved, it is called as true positive. It is non-relevant but it is still get retrieved, that is called false positive. So this case is false positive. The documents are relevant but not retrieved, that comes under the falsely negative. So this comes under the false negative, and true negative means it is non-relevant and non-retrieved, that is TN. The formula for precision is TP divided by TP plus FE, that is true positive divided by TP plus FP, that is whatever documents retrieved, they may be relevant or may non-relevant, but when non-relevancy is increases, the precision reduces. Recall is true positive divided by TP plus FN, that is relevant and retrieved divided by, this is nothing but if we add this column, then we are getting relevant documents in the system, that is TP plus FN. So when we are seeing the precision, we require to see this row, and when we are seeing the recall, we require to see this row. And don't change predicted and actual, because the formula becomes, there is need to change the formula. So recall is 1 when Fn is equal to 0, since 100% of the TP were discovered. See this. And precision is 1 when, precision is 1 when Fp is equal to 0, since nowhere spurious result. So in this way we can remember the precision and recall in a easiest way. Now this is the true positive, which is actually relevant and retrieved. This is expected but it didn't get retrieved, that is it become falsely negative. And this is nothing but false positive, that is they are not relevant but still get retrieved. And this is nothing but not retrieved and not relevant. So we can represent this precision and recall using the Venn diagram also. Now we will see the example. Total 16 documents are there. For a given query, 8 are relevant and 8 are non-relevant. For a given query, system retrieves 10 documents, 4 are relevant and 6 are non-relevant. So first we will write down this table. Now here total 10 documents get retrieved, so retrieved is 10. In the system total 16 documents are there, and for a given query 8 are relevant and 8 are non-relevant. So total 16 documents in the system, that is actual, in which 8 are relevant and 8 are not relevant. Total documents get retrieved are 10, and out of 10, 1, 2, 3, 4 are relevant. Therefore relevant and retrieved are 4, and 6 documents they are not relevant but still get retrieved. Therefore this score is 6, and we can write down the other value easily. And when we can see that for calculation of precision and recall, we require only these three values, TP, FP and Fn. When we call the precision, it is TP divided by TP plus FP, and when we calculate recall, it is TP divided by TP plus Fn. So we can easily calculate. So this calculation is very easy, no need to understand. That is a simple formula. So TP divided by TP plus FP. Only important is to understand the problem and to fill this table. After that, precision and recall is very easy. Even we can calculate like this: 4 divided by 4 plus 6 and 4 divided by 4 plus 4. Now see the example 2. Total 10 documents are there. Relevant to our need are 5. That is that for particular query 5 documents are relevant. So total 10 documents are there. For a given query, 5 are relevant, 5 are non-relevant. So we fill this. Now query is given, and out of that 6 documents get retrieved. So retrieved is 6, and we can see that only D4, D5 and D8, they are the relevant and they gets retrieved. All other comes under the case of FP, which are D2, D6, D9. And once we fill this, we can easily find out this Fn and Tn value. So in this way, we can first understand the problem, find out the relevant document, find out the total number of retrieved document, and in this way we calculate the precision and recall. So precision is in the denominator, it is always the total number of retrieved documents, and for the recall, the denominator is always total number of relevant documents present in the system. Find total retrieved, total not retrieved, precision and recall. So total retrieved are 6, total not retrieved are 4. So this table is given, and we just require to find out what is total retrieved, total not retrieved, and based on that we can easily calculate the precision and recall value. Consider a program for recognizing dogs. Now here dogs become the relevant document in a digital photograph. So total cats are 10 and dogs are 12. So dogs are relevant here and cats are non-relevant. Therefore relevant becomes 12, non-relevant becomes 10. The program identifies 8 dogs, means it retrieves the 8 documents. So retrieved is 8. Out of that only 5 are dogs. So 5 are dogs. So retrieved but they are not relevant are 3. So we can easily fill, once we know this value, and after that we can fill the remember. Now here retrieved are 8. So non-retrieved are total 22. So retrieved are 14. And once we know these two values, we can fill the remain, and we can easily calculate the precision recall. So we require to understand the problem statement carefully, and what is total number of relevant, what is total number of retrieved, that becomes the denominator for recall and precision. And after that we require to identify TP, FP and Fn. When a search engine returns 30 pages, only 20 out of which are relevant, and while failing to return 40 additional relevant pages. Now as we solve the problem, and we found out that Tn is not actually required. So in some of the problem statement Tn is not given. So only we require to calculate the precision recall. So we require to concentrate only on these 3 values. Now when a search engine returns 30 pages, that is it returns 30 pages, out of which 20 are relevant, therefore 10 becomes irrelevant. Now here when search engine reaches 30 pages, while failing to return 40 additional relevant pages, so it indicates that it didn't return the 40 relevant pages. So it becomes 40, they don't not return, so it becomes a falsely negative. So this is 20, 10 and this is 40, and based on that we can calculate the precision and recall. So in this way we require to understand the problem statement, complete the table, and once the table is correct, precision and recall is very easy to calculate. IR system returns 6 relevant documents, 10 non-relevant documents. There are total 20 relevant documents. So 20, this means these 20 documents, 6 relevant return, 10 non-relevant documents written. So we can get this 16, this 20. We can calculate the Fn, and based on that we can calculate precision and recall. So example solving is very easy, only to understand the problem statement and put the values into the confusion matrix. Similar example. So I am not explaining this example. You just watch the problem statement and try to fill this value. Similar for the next example. Now we'll see the next problem. The problem comes like this also. For a given query, there are 20 relevant documents in the collection. The precision of the query is 0.50, and for the recall query, for recall score is 0.35. How many documents are there in the result set? Now we will see first recall. Recall is relevant items retrieved divided by total relevant items in the system. Now recall score is 0.35, and it is given that total number of relevant documents in the collection are 20. So for denominator, for recall function, denominator is 20. So we will get relevant items which are retrieved. So the relevant items retrieved, by this formula we are getting the 7. So recall is 0.35. Total number of relevant documents are 20. So 0.35 into 20 is equal to 7. Now precision score is also given. Precision is equal to relevant items retrieved divided by retrieved items. It is 0.35, and this is nothing but numerator is 7, which is relevant and retrieved. Now by this way, retrieved items are 14. So total 14 documents are there in the result set, and they are 7 are relevant and 7 are non-relevant. Now this is very important observation, and even by seeing the problem we can easily make the conclusion. Precision can be seen as a measure of quality, because whenever relevant items get retrieved, the precision increases, and recall as a measure of quantity. For example, in our system, if 10 documents are relevant, and as we are retrieving the documents, the recall relevant document retrieved, the recall increases. So recall does not check whether in between whether relevant irrelevant documents get retrieved or not, but precision check on that. Higher precision means that an algorithm returns more relevant results than irrelevant ones, and high recall means that algorithm returns most of the relevant results. A high value of precision means large part of the retrieved documents are relevant, because the precision is very sensitive. When irrelevant documents retrieved, precision decreases, and when relevant documents retrieved, the precision increases. Web surfers would like every result on the first page to be relevant, that is high precision, but user have not the slightest interest in knowing or looking at every document that is relevant. A high value of recall means large part of the relevant documents are retrieved. Professional researchers are very concerned with the trying to get high recall as possible, because in between searching, even they get the wrong result, they are okay, but they want to find out whatever the relevant documents present for that particular topic in the collection. Precision recall trade-off. Recall is non-decreasing function of the documents retrieved, because as more and more documents retrieved, the chances of relevance is more. On the other hand, in good system, the precision usually decreases as the number of documents retrieved is increased, because it is sensitive to wrong retrieval, and wrong retrieval means score of the precision is reduced. Now precision at the rth position. Now precision at the rth position means we require to check, r is nothing but the recall, so we require to check what is the total number of relevant documents in the system. So precision at the rth position is ranking of the result for a query that has r relevant documents. Now example is given, and here in the system total number of relevant documents are 6. Now here the documents retrieved are 1 2 3 4 5. Now we require to total number of relevant documents are 6. Now p is equal to 4 by 6. Now precision at the rth position. Now we require to take documents are 6, so we are checking at the 6th position, and at 6th position we can see that only 4 documents which are relevant retrieved. That's why it is a precision, so numerator is relevant and retrieved. So up to 6th position 4 documents are relevant which gets retrieved, and divided by denominator we are getting total number of documents retrieved, that is nothing but 6. So we require to take the precision at the R location, and R is nothing but the total number of relevant documents in the system. Next measure is accuracy, but accuracy we are going to rarely used in the information retrieval. The fraction of correctly classified documents is obtained by accuracy, where accuracy is TP plus TN by N, and we found that when we are using precision and recall only TP, FP and FN is used, but we are not using the TN. Now accuracy formula is TP plus TN divided by N, where N is total number of documents in the collection. But for IR system most of the documents are non-relevant, so it would be relatively easy to find out the non-relevant documents. If an IR system is tuned to maximize its accuracy, it is likely to classify all documents are non-relevant, means the system will have high TN. But if user want to see some documents, even they are wrong, but user want to see that documents, that is TP plus FP, that is true positive, and the documents which gets falsely positive with a relatively large TP and small FP. Therefore precision, recall and F measure are used for evaluation rather than accuracy. So accuracy for IR systems is rarely used. Now accuracy is TP plus TN divided by N, where TP is nothing but the accuracy is the fraction of TP, that is the which is shown in the this is the exactly TP, that is true positive is actually in orange, and the true negative is in the pink color. So just that color change, this is nothing but the true positive and this is nothing but the true negative. So this is nothing but orange plus pink divided by entire area, that is nothing but the accuracy. So here you just make some correction, that is the color gets changed. Now we'll see the F1-Score. F1-Score is a way to combine precision and recall in one metric. It is easy to evaluate the quality with just one number, not two. If we give F1-Score when average across precision and recall, the values we get. Now if we want to use F1-Score, and to calculate the F1-Score we are considering the precision and recall, but if we take simply average of precision and recall as F-score, that is not a good measure. Now see this example. Classifier 1 with precision 0.5 and recall 0.5. So see this table, you can easily get the idea, that is here precision is 1/2 and recall is also 1/2, that is 0.5 0.5, and this is the classifier 2 where precision is 1 because 1 divided by 1 plus 0 is 1, and recall is 0.0001. Both classifier, if we take the average, then both classifier will get the score as 0.5, although it is clear that the first classifier is much better than the second classifier by seeing this confusion matrix. F1-Score, simple average of precision and recall is a bad idea. So that's why in F1-Score we are getting the weighted average, that is nothing but the harmonic mean, and which gives us the good result. So F1-Score, if we take the simple average, this is the formula, but if we are using the harmonic mean, our formula becomes 2 into precision into recall divided by precision plus recall. Now we will see the same example. Classifier 1 2, precision 0.5, recall 0.5, precision 1, recall is 0.001. If we take the simple average, we can see that results are similar and we can't compare the two classifier whether they are good or bad. But if we use the F1-Score, here we can easily see the difference. That's why for F1-Score we are not going for a simple average, but we are going for the harmonic mean. The range of F is between 0 to 1. When F equal to 1, all retrieved documents are relevant, and when F equal to 0, no relevant documents have been retrieved. Precision of 1, every single prediction the model makes as positive as indeed as a true positive, there are no false positive. And recall of 1, the model correctly identifies all actual positive instances and there are no false negative. Balancing act. The F1-Score expertly balances precision and recall, sensitivity to imbalance. Unlike a simple average, the harmonic mean used in F1 is highly sensitive to low values in either precision or recall. This means if either metric is significantly less than 1, the F1 score will also be low, highlighting the potential issue. So this is the beauty of F1 score, which will identify the imbalance between the precision and recall. Now we'll see this example. Calculate precision recall at each retrieval and F1 score after the 6 documents get retrieved. Now here these are the relevant documents. Now the first document gets retrieved and which is relevant. So precision is relevant retrieved divided by total number of retrieved document, which is equal to 1. Recall is, in the recall we can see that denominator all values are 6 because total number of relevant documents in the system is 6. So relevant retrieved, therefore 1 by 6, it is 0.70. 1 by 2. Now second documents is non-relevant, so numerator is 1 because only one relevant documents get retrieved divided by total number of retrieved documents, which are 2, that is 1 by 2 equal to 0.5. Now we see that when irrelevant documents get retrieved, the precision decreases but recall does not decrease. So recall remains same, but when again relevant documents comes into the picture, precision also increases and recall is also increases. So in this way we can find out. Now we require to find out at the 6 document retrieval, and here both recall and precision, they are the same. So we are taking this result. So it is very easy to calculate precision recall and F1 score. Same at third, it is 0.33 and 0.67, and we are using that F1 score formula to calculate the F1 score. So in this way we are getting the answer. Calculate precision recall and F1 score for a given confusion matrix. So as we know how to calculate the precision recall, only we require to put the value into the harmonic mean of the F1 score, and by that we can calculate the F score also. So this is the simplest example. No need to explain, it is just values are given in the confusion matrix, and we just require to remember the formula for precision recall and F1 score. Again the next example is also easy. Now here 3 documents are given, document number relevant, and this information is required because when we calculate the recall we require the total number of relevant documents present in the system. So total number of relevant documents are 2, only one relevant is retrieved out of 3, so precision is 1 by 3 and recall is 1 by 2, and we can easily calculate the F score. Calculate the precision at each step. Now here the total number of relevant documents are 3, so when relevant documents get retrieved, then only the numerator is increased and there is a change in precision score. For recall, when irrelevant documents get retrieved, it remains same, but when relevant documents get retrieved, it increases. And we can see that total 3 documents are there, and when they get retrieved, we are getting the recall 1. So when from a system, when we retrieved all documents, and in that case it becomes that all relevant documents get retrieved, so finally our recall becomes 1. That's why when we draw that graph, the graph becomes like this. 1 minute. Graph like this, because at last our recall becomes 1, because whatever documents present in the system gets retrieved. Calculate the precision and recall at this stage, 0.2, 0.4, 0.6, 0.8. Total relevant documents are 5. So when we retrieved one relevant documents, recall becomes 1 by 5, then 2 by 5, 3 by 5, 4 by 5 and 5 by 5. So S1 and S2 systems are given, and we require to find out the precision whenever these documents get retrieved, 1, 2, 3, 4, 5, and for this 1 2 3 4 5 the formula is same, only in the numerator that relevant retrieved count and denominator total number of documents retrieved. So this example is also very easy. Now 12 documents are given, and here judge 1 and judges 2 are used to determine whether this document is relevant or non-relevant for a given query. So we are using the decision by the two judges. So for that system, when 0 is non-relevant and 1 is relevant, and we are assuming that first problem that the document is relevant only when two judges are agree. Now here we require to first find out total number of relevant documents present in the system, because it is needed to calculate the F1 score as well as recall. Now here the out of 12 documents where the document is relevant when both judges agree, that is this third document and fourth document. So total number of relevant documents are 2, but out of that only 4 5 6 7 8 gets retrieved, and we can check that 4 5 6 7 8. Therefore for the precision denominator is 5 and numerator is only 1, because only one document which is relevant gets retrieved, and recall is out of in the system 2 documents are relevant and only one gets retrieved, so it is 1 by 2. So in this way we require to check. So it is very important to know the number of relevant documents present in the system. Now here we require to check the document is relevant if either one of the judges agree. So we require to take the combination of 0 1. So when we observe all 12 documents, we can see that only these two are non-relevant, all others are relevant. So total number of relevant documents are 10. Out of that 4 5 6 7 get retrieved. So 1 2 3 4 5. So denominator by 5 and all are relevant. So 5 by 5 and recall is 5 by 10. eMeasure extends the F1 score ability to balance precision and recall by introducing a customizable weighting factor beta. So this formula is also again modified with the beta. So when beta is greater than 1, it emphasizes the recall, prioritizing the finding more relevant documents useful for tasks like literature search or legal discovery. Beta equal to 1, equivalent to traditional F1 score, and balancing the precision and recall equally. When beta is less than 1, it emphasizes the precision, ensuring the higher proportion of retrieved documents are relevant, suitable for spam filtering or medical diagnosis. So based on our application need, we require to tune this beta parameter to get the good results. Therefore, the choice of beta should be aligned with specific goals and priorities of the higher task. So these are the references used for this PPT presentation. Now this is the exercise. This is a simple exercise. Only read the problem carefully and just fill the value in the confusion matrix. So whatever the question marks you try to fill for the practice, and after that it is very easy to calculate the precision, recall and the F1 score for the system. So this is all about the unranked retrieval for IR evaluation system. In the next video I am going to explain the rank retrieval. Thank you.